On June 20, 2025, Landspace, a Chinese launch startup, achieved a significant milestone in the development of its Zhuque-3 rocket by successfully conducting a static fire test. This event took place at the Dongfeng Commercial Space Innovation Test Zone located near the Zhuque-3 Satellite Launch Center in northwest China. The test involved igniting 9 of the rocket's self-developed Tianke-12 methane-liquid oxygen engines in sequence, lasting a total of 45 seconds and producing an impressive thrust of 7,542 kN. This successful test is a pivotal step toward Landspace's objective of launching the Zhuque-3 into orbit, with its inaugural flight anticipated later in 2025. Technical details of the test. The static fire test utilized the actual first-stage structure intended for the Zhuque-3's maiden flight. All stages of the pre-launch sequence were replicated, including propellant loading, tank pressurization, and engine ignition. The engines were ignited in parallel. Representing China's largest and most automated engine cluster test to date. This meticulous preparation is crucial for validating the rocket systems and ensuring compatibility among various subsystems such as engines, pressurization, delivery systems, and avionics. Future plans and launch capabilities. The Zhuque-3 rocket is designed with reusability in mind, aiming for at least 20 recoveries of its first stage. With a liftoff weight of approximately 570 metric tons and a length of about 66 meters, the Zhuque-3 is capable of carrying various payload capacities to low Earth orbit (LEO). It can deliver up to 21,000 kilograms when expended, 18,300 kilograms when the first stage is recovered downrange, and 12,500 kilograms when returning to the launch site. This flexibility in payload capacity is a significant advantage in a competitive launch market. Significance in the broader context. The successful static fire test is a critical milestone in China's broader efforts to develop reusable launch vehicle technology. This innovation aims to significantly reduce launch costs, with Landspace indicating potential savings of 80 to 90% compared to traditional single-use rockets. This advancement aligns with global aerospace trends, where reusability is increasingly essential for economic viability and sustainability in space exploration and satellite deployment. Timeline of events leading to the test. October 2018, Landspace's first launch attempt with the Zhuque-1 rocket fails. July 2023, the Zhuque-2 becomes the first methane-liquid oxygen rocket to reach orbit. September 2024, Landspace conducts a 10-kilometer altitude launch and landing test with a prototype first stage. June 20, 2025, successful static fire test for the Zhuque-3. Paving the way for its inaugural flight, originally planned for the third quarter of 2025. Conclusion. The static fire test of the Zhuque-3 rocket represents a significant leap forward for Landspace and China's ambitions within the competitive space industry. As Landspace continues to refine its technology and prepares for the inaugural flight, the implications of this achievement extend beyond mere milestones. They signify a commitment to innovation, cost-effectiveness, and the future of space exploration in an era where reusable technology is becoming increasingly vital. The successful completion of this test positions Landspace as a serious contender in the global aerospace sector, paving the way for further developments and potential collaborations in the future. The content surrounding Landspace's Zhuque-3 rocket and its successful static fire test reveals several counterintuitive points regarding the development of reusable rocket technology in China. 1. Misconceptions about China's space industry. Many people perceive China's space industry as primarily state-run and less innovative than its Western counterparts. However, the establishment of private companies like Landspace demonstrates a burgeoning entrepreneurial spirit in China's aerospace sector, which is capable of achieving significant milestones such as the successful static fire test of Zhuque-3. This challenges the conventional view that innovation in China's space program is solely a product of government initiatives. 2. Cost reduction expectations. While the content states that Landspace technology could reduce launch costs by 80 to 90% compared to traditional single-use rockets, This figure seems overly optimistic given the complexities involved in making rockets reusable. Historically, achieving such drastic cost reductions has proven difficult for various space agencies and companies worldwide. The expectation of reusability leading to such extreme cost savings may be more aspirational than practical, as the actual implementation often encounters unforeseen challenges and expenses. 3. Comparison to established systems. The Zhuque-3 rocket is compared to SpaceX's Falcon 9, leading to the assumption that it will follow a similar trajectory of success. However, the context of the aerospace market is vastly different now than when Falcon 9 was developed. The increasing competition and technological advancements mean that replicating SpaceX's success is fraught with greater challenges, including market saturation and the need for differentiation in capabilities and cost-effectiveness. For technical feasibility of reusability, the claim that the first stage engine can be checked without separation from the rocket post-recovery suggests a level of operational efficiency akin to commercial aviation. However, this presents a counterintuitive notion, since the operational realities of space travel are much more complex than those of aviation. The rigorous conditions of rocket launches and landings, as well as the intricate nature of engine systems, imply that achieving a similar maintenance routine will likely be more complicated than anticipated. 5. Integration challenges. The successful static fire test represents a significant technical achievement, yet it does not guarantee that subsequent phases such as reaching orbit and ensuring safe recovery will proceed without issues. The content implies a linear progression from static fire to orbital launch, which is counterintuitive considering the historical challenges faced in rocket development, where each phase often reveals new technical hurdles. 6. A global competition environment. The narrative emphasizes China's advancements in reusable technology while positioning Landspace as a key player in a competitive global landscape. However, the rapid evolution of reusable space technology worldwide presents a paradox. While China's capabilities are expanding, it is also facing increasing competition from both traditional space powers and emerging private companies in other regions, which could dilute its competitive edge. 7. Regulatory implications. The notion that increased launch frequency could lead to environmental concerns such as ozone layer depletion is a critical insight that runs counter to the general perception that space exploration is devoid of significant environmental impact. This highlights the need for responsible growth in the space sector, suggesting that the expansion of commercial spaceflight could have unintended ecological consequences. These counterintuitive points challenge commonly held beliefs and assumptions about China's space ambitions, the feasibility of reusable rocket technology, and the broader implications of increased competition in the aerospace industry. They reflect the complexities and unpredictabilities inherent in the rapidly evolving field of space exploration. The successful static fire test of the Zhuque-3 rocket by Landspace on June 20, 2025 is a significant milestone in the field of reusable rocket technology and marks a key development in China's growing role in the global aerospace industry. While many aspects of this achievement have been covered in various reports, there are critical details that some may overlook, which can provide deeper insights into the implications of this event. 1. Automation and engineering complexity. One of the standout features of the Zhuque-3 static fire test is the claim that it represents China's largest and most automated engine cluster test to date. The test involved igniting 9 engines in parallel, a feat that not only demonstrates significant engineering prowess but also highlights advances in automation technology within the aerospace sector. Significance: this level of automation reduces human error and increases the reliability of rocket launches. As aerospace companies push towards higher launch cadences, automated systems will be essential for streamlining operations and managing complex testing sequences. The successful execution of such a test could set a precedent for future rocket designs globally, encouraging other companies to invest in similar automation technologies. 2. Cost reduction potential. Landspace has emphasized that the Zhuque-3 rocket could potentially reduce launch costs by 80 to 90% compared to traditional single-use rockets. This claim is supported by the reusable design of the Zhuque-3, which is engineered for at least 20 reuse cycles. Significance: if successful, this cost reduction could democratize access to space for smaller nations and private companies, fostering innovation in satellite technology and other space applications. The economic implications extend beyond launch costs. Reduced costs could lead to an increase in the frequency and diversity of satellite deployments, enhancing global communications scientific research and environmental monitoring. 3. Integration with China's space strategy. The Zhuque-3 rocket is part of a broader strategy by China to establish itself as a leader in the space industry. The rocket is intended to facilitate low-cost cargo delivery to the Tiangong space station. The test's success aligns with China's ambitions to enhance its capabilities in space exploration and commercial satellite launches. Significance: this development is indicative of a strategic shift where China is not only catching up with established players like SpaceX but could potentially outpace them in specific areas of reusable technology. The implications for international relations and competition in space are profound, as nations may seek to align with or counterbalance China's growing influence in the aerospace sector. 4. Technical validation and future challenges. The static fire test validated multiple subsystems, including engines, pressurization, and avionics, ensuring that they work seamlessly together. However, while the static fire test was a success, there are still significant challenges ahead, such as achieving orbit, ensuring safe recovery of the first stage, and demonstrating the rocket's reusability. Significance: the technical validation achieved in this test is crucial for building confidence in the Zhuque-3 program. However, the challenges that lie ahead highlight the precarious nature of aerospace developments. The transition from successful ground tests to actual flight operations is fraught with risk, and setbacks in subsequent testing could impact timelines and investment in the project. Understanding that the road to operational launches is complex can temper expectations and encourage a more cautious perspective on rapid advancements. 5. Global competitive landscape. The Zhuque-3's development occurs within a context of increasing competition among various countries and private companies in the space sector. Other companies such as SpaceX have already established a stronghold in reusable rocket technology, and the success of Zhuque-3 could shift competitive dynamics. Significance: the competitive landscape is not just about technological capabilities but also involves market share and geopolitics. A successful Zhuque-3 launch could allow China to capture a portion of the global launch market, particularly as demand for satellite launches increases. This could lead to strategic partnerships or tensions as nations vie for dominance in space. 6. Environmental considerations. The environmental implications of increased rocket launches, particularly in relation to ozone layer recovery, should not be overlooked. Reports suggest that a significant increase in rocket launches could potentially hinder the recovery of the ozone layer due to emissions from rocket fuels. Significance: as the space industry grows, it will be important for companies and governments to consider the environmental impact of their activities. This could lead to regulatory changes or initiatives aimed at ensuring sustainable practices within the aerospace sector. The conversation around environmental responsibility in space exploration is becoming increasingly relevant and could influence public perception and policy. Conclusion: the successful static fire test of the Zhuque-3 rocket is more than just a technical achievement. It represents a confluence of automation, economic opportunity, strategic positioning, and environmental considerations. Understanding these nuances can provide a clearer picture of the future trajectory of space exploration and the role of reusable technology within that landscape. As Landspace moves closer to its inaugural flight, the global aerospace community will watch closely, not just for the success of the Zhuque-3 but for the broader implications that this development may have on the future of space access and exploration. 1. Technical details of the test. The static fire test of the Zhuque-3 rocket conducted by Landspace represents a critical advancement in rocket technology, particularly in the realm of reusable launch systems. This test involved igniting 9 of the Tianke-12 methane-liquid oxygen engines in sequence for 45 seconds, generating a total thrust of 7,542 kN. The significance of this test lies in its meticulous simulation of actual flight conditions, covering every aspect from propellant loading to engine ignition and shutdown. This level of sophistication in ground-based testing is indicative of Landspace's commitment to ensuring reliability and performance in their launch systems. The use of all 9 engines in parallel for the first time marks China's largest and most automated engine cluster test to date, showcasing the technological prowess of Landspace and the evolving capabilities of China's aerospace sector. The successful execution of this test not only validates the engineering designs but also highlights the company's readiness for its upcoming orbital launch, demonstrating the rigorous approach taken to ensure that all subsystems, engine pressurization and avionics work in harmony. 2. Future plans and launch capabilities. The Zhuque-3 rocket is a significant player in the shift toward reusable rocketry, with plans for its first stage to be recovered and reused at least 20 times. This capability drastically alters the economics of space launches. With a liftoff weight of approximately 570 metric tons and a length of about 66 meters, the Zhuque-3 is engineered for versatility and payload capacity. It can carry up to 21,000 kilograms to low Earth orbit LEO in an expendable configuration, while the recovery of the first stage allows for payload capacities of 18,300 kilograms downrange and 12,500 kilograms when returning to the launch site. This adaptability positions Zhuque-3 as a competitive alternative to existing launch vehicles, particularly in a market increasingly focused on cost efficiency and sustainability. The anticipated reduction in launch costs by 80 to 90% compared to traditional expendable rockets could democratize access to space, paving the way for more commercial satellite deployments and scientific missions. As Landspace prepares for its inaugural flight, these capabilities will be crucial for attracting both governmental and commercial customers who are increasingly looking for cost-effective launch solutions. 3. Significance in the broader context. The successful static fire test of the Zhuque-3 rocket is not just a milestone for Landspace but also a reflection of China's broader ambitions in the global space race. This achievement aligns with a global trend toward reusable launch vehicles, crucial for reducing the financial barriers associated with space exploration and satellite deployment. Landspace's assertion that its technology could cut costs by up to 90% underlines the economic implications of successful reusable rockets and their potential to transform the aerospace industry. Moreover, this test signifies China's commitment to advancing its space capabilities in alignment with national goals such as enhancing its presence in the commercial space sector and developing infrastructure for future missions, including those related to the Tiangong space station. The successful development of reusable rockets could position China as a leader in the global space economy, especially as the demand for satellite launches continues to surge. This ambition is further reflected in the ongoing investments in the space sector and the emergence of private companies like Landspace, which are now able to operate alongside state-owned enterprises. 4. Timeline of events. Understanding the historical context leading up to the static fire test provides insight into Landspace's development trajectory and the challenges faced along the way. The timeline reveals a series of significant milestones, starting with Landspace's first launch attempt of Zhuque-1 in October 2018, which ended in failure. This setback led to a pivot toward the Zhuque-2, which successfully became the first methane-liquid oxygen rocket to reach orbit in July 2023. The progression continued with a successful 10-kilometer altitude launch and landing test in September 2024, culminating in the recent static fire test on June 20, 2025. This sequence illustrates the iterative nature of rocket development, where each test builds on previous experiences and informs future designs. The planned inaugural flight of the Zhuque-3 later in 2025 is a critical next step not only for Landspace but also for China's positioning in the competitive landscape of global space exploration. This timeline underscores the resilience and innovation necessary in the aerospace industry, where each milestone contributes to a larger vision of sustainable and economically viable space access. Conclusion. The successful static fire test of the Zhuque-3 rocket represents a pivotal moment for Landspace and the Chinese aerospace sector as a whole. It embodies the technological advancements necessary for developing reusable rocket systems, showcases the company's ambitious plans for future launches, and aligns with global trends towards sustainability and cost efficiency in space exploration. As Landspace prepares for its inaugural flight, the implications of this test extend beyond immediate technical achievements, highlighting the broader context of competition and innovation in the rapidly evolving space industry. 1. NASA's Space Shuttle Program 1981 to 2011. The Space Shuttle program is one of the most notable examples of reusable rocket technology in history. NASA developed the Space Shuttle to transport astronauts and cargo to and from low Earth orbit. The shuttle was designed to be reused multiple times, with the orbiter capable of flying up to 150 missions over its lifetime. The program completed a total of 135 missions, with shuttles being refurbished after each flight. The reusable nature of the shuttle allowed for significant cost savings in launching payloads, although the expenses related to refurbishment and maintenance were high. The program faced challenges including two tragic disasters: Challenger in 1986 and Columbia in 2003, which highlighted risks associated with reusable launch systems. 2. SpaceX Falcon 9 2010 present. SpaceX's Falcon 9 rocket has revolutionized the space industry with its reusability. The Falcon 9 is designed to have its first stage land back on Earth after launch, allowing it to be refurbished and reused for subsequent missions. This approach drastically reduces the cost of access to space. SpaceX has successfully landed and reused Falcon 9 first stages dozens of times since its first reuse in 2017. The successful static fire tests and subsequent launches have set new standards for reusability in the industry, making it a prime case study for future developments in launch vehicle technology. 3. Blue Origin's New Shepard 2015 present. Blue Origin developed the New Shepard suborbital rocket system with a focus on reusability. New Shepard is designed for short flights to the edge of space, primarily for suborbital tourism and scientific research. The rocket's first stage is capable of returning to the launch site and landing vertically after each flight, allowing it to be refurbished for multiple missions. Blue Origin has conducted numerous successful flight tests, demonstrating its reusability model. The program emphasizes the growing trend of developing reliable and cost-effective reusable launch systems, contributing to the accessibility of space travel. The successful static fire test of Landspace Zhuque-3 rocket on June 20, 2025 represents a pivotal moment in the realm of reusable rocket technology, particularly for China's rapidly advancing space sector. As we look to the future, several key predictions can be made about the implications of this achievement and the broader trajectory of space exploration and commercial spaceflight. 1. Advancements in reusable rocket technology. The Zhuque-3's design emphasizes reusability with expectations of at least 20 flights from its first stage. This is aligned with global trends where major players like SpaceX have successfully demonstrated the economic viability of reusing rocket components. By significantly reducing launch costs, potentially by 80–90%, Landspace may set a new standard for affordable access to space, particularly for small to medium-sized satellite operators and commercial payloads. As reusability becomes the norm rather than the exception, we can anticipate a surge in the frequency of launches. This could lead to lower prices for satellite launches, spurring innovation in satellite technology and applications and prompting a new era of space-based services from broadband internet to Earth observation. 2. Increased competition in the global launch market. The Zhuque-3's impending maiden flight positions Landspace as a serious competitor in the global launch market. With the successful static fire test, Landspace enhances China's capabilities in commercial spaceflight previously dominated by established entities like SpaceX and Arianespace. As more companies, including those from Japan and India, enter the reusable rocket sector, we can expect heightened competition. This competition will likely drive innovation, improve service delivery, and further lower costs, benefiting end users and potentially leading to a renaissance in satellite deployment and space exploration initiatives. 3. Strategic implications for China's space program. The success of the Zhuque-3 static fire test aligns with China's broader ambitions in space, including its plans for the Tiangong space station and lunar exploration efforts. By mastering reusable rocket technology, China could enhance its capability to deploy and service its own satellites, astronauts, and cargo more efficiently, thereby solidifying its position as a leading space power. In the context of geopolitical dynamics, advancements in space technology could also play a role in national security and defense strategies as countries increasingly recognize the strategic importance of space. 4. Environmental considerations and sustainability efforts. As the frequency of rocket launches increases, so too does the attention to the environmental impact of space activities. The potential for ozone layer depletion due to rocket emissions, as highlighted in recent studies, underscores the need for sustainable practices in the aerospace industry. Landspace's focus on methane as a fuel for the Zhuque-3 is a step towards more environmentally friendly propulsion systems, as methane is considered less harmful than traditional rocket fuels. Future developments in green propulsion technologies will be essential for mitigating the environmental impacts of the burgeoning space launch sector. 5. Integration of space technology into daily life. With lower costs and increased launch capabilities, we can expect a significant integration of space technology into everyday life. The next decade could see advancements in satellite communications, Earth observation, and global broadband internet access through megaconstellations. As companies like Landspace and SpaceX launch more satellite services such as real-time weather monitoring, disaster response, precision agriculture, and enhanced telecommunications will likely become more accessible to both developed and developing nations. 6. Collaborative efforts in space exploration. The advancement of reusable technology may also pave the way for collaborative international efforts in space exploration. As various countries and private entities demonstrate their capabilities, partnerships may form to share resources and knowledge, leading to joint missions and cooperative endeavors in areas such as lunar exploration and Mars missions. Conclusion. The successful static fire test of the Zhuque-3 rocket by Landspace is not merely an isolated achievement, it is a significant milestone that heralds a new chapter in the global space arena. As we look ahead, the implications of this success will resonate across technological, economic, and geopolitical landscapes, shaping the future of space exploration and commercial activities for years to come. The landscape of space will continue to evolve, rapidly characterized by innovation, competition, sustainability, and collaboration.